All right, today we're going to dive into a really powerful new way to think about large language models, and it's all inspired by the great Andrej Karpathy. We're going to build an intuition not just for what these things are, but maybe more importantly, what they're on their way to becoming. So let me just start with a big question. What if that chatbot you've been playing with isn't really a chatbot at all? What if it's the beginning of a totally new kind of operating system? For anyone with an engineering background, this one idea, this analogy, it's the key to everything. So here's our game plan. First, we're going to break an LLM down to its absolute basics, a machine made of just 2 files. Then we'll look at how it gets its smarts by basically compressing the internet. After that, we'll see the pivot from just answering questions to actually doing things. And all of that builds up to the main event, the LLM as an operating system. And of course, a new OS means new threats. Okay, first up, let's pull back the curtain and demystify this machine. We tend to think of LLMs as these magical, complex things living in the cloud. But at their core, they're surprisingly simple and concrete. So Karpathy has this brilliant way of explaining it. To run a massive model like Llama 2, you really only need 2 things. First, a gigantic file of parameters. That's the brain. And second, a surprisingly simple little program to run it all. The whole thing is totally self-contained. You can run it on your own machine. This tells you something really important. The magic isn't in the code that runs the model. It's baked into those billions and billions of parameters. Okay, so if we're running the model is pretty straightforward, where does all the crazy complexity come from? Well, it's all in the process of creating those parameters. And it's not really learning like a human does. It's more like data compression on a scale that is just hard to wrap your head around. The best way to think about training is as a massive lossy compression algorithm. You take a huge chunk of the internet with all its knowledge and patterns, and you squeeze it down into that single parameter file. It's kind of like a zip file of human culture, It loses some of the fine details, but it keeps the core concepts. And just to give you a sense of the scale here, to create Llama 2, they started with 10 times terabytes of raw text scraped from the internet. Then they threw 6,000 GPUs at it, running nonstop for 12 days. And the price tag for just that one training run, over $2 million. And like Karpathy says, these numbers are practically ancient history now. Pre-training is a heavy industrial scale process. But here's the wild part. All of that insane industrial scale computation, it's all in service of one ridiculously simple goal: predict the next word. That's it. But by doing that task trillions of times, the model is forced to build this deep internal representation of grammar, logic, facts, really a model of the world. And all of that gets compressed into the parameters. So what you get from all that training is what's called a base model. And honestly, it's kind of like an internet document dreamer. It's full of knowledge, but it's not very useful. To make it useful, you have to turn it into a helpful assistant that doesn't just answer questions, but actually acts. And that's where fine-tuning comes in. It's a much, much cheaper process. You just show it a bunch of high-quality examples of questions and answers. So if pre-training builds the model's raw knowledge, you can think of fine-tuning as teaching it style and manners. It's how you get it to behave like a helpful assistant. Now, a properly fine-tuned model doesn't just pull answers from memory, it acts. So for a complicated question like this one, it doesn't just guess. It actually forms a plan. It decides, okay, first I need to hit the web browser to get some data. Some data's missing? I'll call the calculator. And finally, I'll fire up a Python interpreter to plot the results. The key insight here is the LLM isn't doing the math or the coding itself. It's the conductor of the orchestra, delegating tasks to other specialized programs. And that right there, that role as the orchestrator, is what brings us to the core idea of this whole explainer. We can finally make the analogy official. The LLM is a new kind of operating system. Karpathy just nails it with this quote. Forget chatbot. It's way more accurate to see it as the kernel of a new OS, one that uses plain English as its command line to marshal resources and get stuff done. And the parallels are just uncanny. Look, every OS needs working memory, right? A traditional OS has RAM. The LLM OS has its context window. That's the limited space it has to hold things in its attention while it's working on a problem. What about long-term memory? Your computer has a hard drive. The LLM OS? It uses its tools to go out and retrieve information from files, databases, or just the web. It's the same memory hierarchy we've always had, just with a new twist. But this is where the analogy gets really powerful for us engineers. A traditional OS uses system calls to talk to hardware and other software, right? Well, the LMOS uses tool calls. In this new world, telling the model to call a Python interpreter, that is the new system call. And this parallel doesn't just stop at the technical level, it actually reflects what's happening in the entire market. For decades, we've had proprietary operating systems like Windows and open source ones like Linux. And today, we're seeing the exact same split, with proprietary models like GPT-4 on one side and open source models like Llama and Mistral on the other. History is repeating itself. So, if this OS analogy is really holding up for how these things work, well then it has to hold up for how they break, too. A brand new operating system paradigm is going to bring a brand new class of threats with it. Look, if you accept the OS model, you have to accept the logical conclusion. It has security exploits. Things like jailbreaking and prompt injection aren't just weird quirks. They are the buffer overflows and the privilege escalations of this new world. There's this classic, kind of infamous jailbreak example. If you ask the model directly how to make napalm, all its safety rules kick in and it'll say no. But if you frame the request as this nostalgic, emotional plea to your dear old grandma who just happened to be a chemical engineer, well, you can trick it into telling you. So why on earth does that work? It's because, at its core, the model is just trying to be a good text predictor. It wants to be helpful and stay in character. The story of the loving grandma becomes so powerful that it literally overrides the safety rules that were fine-tuned into it. It's just trying to be a good actor in the scene you created. And that all brings us to one final, pretty provocative thought to leave you with. If LLMs really are the new OS, and their vulnerabilities can be exploited using nothing but creative language, what in the world is the first great LLM virus going to look like? Thanks for tuning into this explainer.